Factor z squared minus 49. So this is a special type of factoring which we call the difference of two squares. Difference means it's a subtraction problem, and two squares means that the terms are perfect squares. In other words, something times itself gives you z squared, and something times itself gives you 49. So we talk about the pattern or look at the pattern above. Once we've identified the expression as the difference of two squares, we just follow the pattern. So what times itself gives you z squared? So that would be z and z. And then what times itself gives you 49? And that would be 7 and 7. Now to get a negative 49, one of these terms has to be negative and the other positive. We talked about conjugates briefly earlier. These are conjugates of one another. So when we use the distributive property to multiply these, we're not going to have a middle term of z. Factor 64 minus 81x squared. So again, we have two terms. So we're determining whether or not this is the difference of two squares. So difference again means that it has to be subtraction, and that these two have to be perfect squares, and it fits both. 64 is 8 times 8, and 81x squared is 9x times 9x, and again they're separated by a subtraction. Just like we talked about earlier, the first step in all factoring is to remove the greatest common factor. So in this case, we would look to see if anything divided into 64 and 81. And since nothing does, we can go right into our pattern. 64 is 8 times 8, and 81x squared is 9x times 9x. And remember, one of these has to be plus and the other minus. Order does not make a difference. So 8 plus 9x times 8 minus 9x is the same as 8 minus 9x times 8 plus 9x. The next example is also a special factoring case. And again, we notice that we have two terms, and again, separated by a minus sign. But if you look at the exponent, we notice this is a 3 and not a 2. So this can't be the difference of two squares. So another special factoring case would be the difference of cubes. Cubes are something multiplied times itself 3 times that gives you that answer. So this is the difference of two cubes. So we follow a pattern, and the pattern is above. So the first thing that we want to do is to determine what cubed gives us x cubed and what cubed gives us 27. So we know that x to the third power gives us x cubed minus, because the original problem is minus, 3 to the third power gives us 27. So now we're going to use these to get to our final answer. So our first factor is what we have in parentheses, the x minus 3. We're going to use those to write or find our trinomial, the last part. So what we do is we take our first term, which is x, and multiply it times itself. So x times x is x squared. Notice our sign. In this case, it's plus. and then we multiply the 3 times the x. Last, it's a plus sign again because we're multiplying a value times itself. So we're going to multiply the 3 times itself to give us 9. These signs will always be opposite of one another. X squared plus 3x plus 9 is the conjugate. And again, that's why we don't have a middle term. Let's look at another one. Here we have 125 plus 64x cubed. So again, we have two terms, but they're not separated with a minus sign, so immediately the difference of squares is out the window. And again, if we look at the x value, it's a cube. We can factor the sum of cubes and the difference of cubes, where when we deal with squares, we can only factor the difference of squares using that pattern. So now, since nothing divides into 125 and 64x to the third, we determine what cubed gives us each one of these. So 5 to the third power gives us 125, and 4x to the third power gives us 64x to the third. So remember, those together make up our first factor, 5 plus 4x. Now we use that to finish the factoring. The first term, we multiply 5 times 5, which is 25. Now our sign is minus in the middle. Remember, these signs will always be opposite. And we just multiply the 5 times the 4x, which gives us 20x. Last, it's always plus because we're multiplying a number times itself, and what we're multiplying times itself is 4x. So 4x times 4x is 16x squared. Solve the quantity 5 plus v times the quantity 4v plus 2 equals 0. So we use something that's called the zero product rule to help us solve. The zero product rule states that when we're multiplying two values together and the answer is 0, one of these two has to be 0, either A or B. So the way we finish solving this particular problem, since it's already factored, we take each factor and set it to 0 and solve. So in the first one, 5 plus v equals 0. We subtract 5 from both sides. So v would equal -5. That's one of our answers. And for the second one, we isolate. So we're going to subtract 2 from both sides. And this gives us 4v equaling -2. And remember, we're going to divide by our coefficient. So v equals -2 over 4, which reduces to -1/2. So our second answer is v equals -1/2. So our next problem, solve for v. 4v squared equals -24v. So our first step is to set the equation equal to 0. So I'm going to move the 24 over by taking its opposite. So I'm going to add 24v to both sides. So that gives me 4v squared plus 24v equals 0. So I set my equation to equal to 0 when I'm using this technique. And then I factor. Remember, the first step in factoring is to remove the greatest common factor. And something divides into 4 and 24, and that's 4. And they both have v's, so I can factor out of v. And when I divide 4v out of each one, that gives me v plus 24 divided by 4 is 6, and v goes into v evenly. So now I have it in its factored form. So remember, once it's factored, one of those two factors has to equal 0. So we set each factor equal to 0 and solve. So for the first one, since there's nothing to move, I divide both sides by 4, and 0 over anything but 0 equals 0. So one of my answers is 0. And for the second one, I'm isolating, so I need to move the 6 on the other side by taking its opposite. So my other answer is v equals -6. Solve for v squared plus 5v plus 4 equals 0. So I already have the equation set to 0, and now I need to factor. So I look to see if anything divides into all of the terms, and nothing does with the exception of 1. So I'm going to do the factoring. V squared plus 5v plus 4. And I use the AC method. So 1 times 4 is positive 4. And the factors of positive 4 that add to a 5 will be 1 and 4. So just like we did before, we're going to rewrite and then factor by grouping. In the first group, the greatest common factor is v. When I take that out, that gives me v plus 1. And in my second group, the greatest common factor is positive 4. And when I divide positive 4 out of each, it should also give me, and it does, v plus 1. So the greatest common factor is v plus 1. And remember, we're going to divide that out of each term. And that's going to leave me with v plus 4. So now we use our zero product rule, and we're going to set each one of these factors to 0 and solve. So our first answer is -1. And our second answer would be -4. And you can always check these answers as well by plugging them in one at a time. -1 for v and making sure it equals 0. And then once you've done that, you'd plug in -4 for each v to make sure that that would equal 0 as well. Solve for y. 2y squared equals 9y plus 5. So again, the first thing we want to do is set this to 0. So we're going to move 9y on the other side and 5 on the other side by taking their opposites. So that would give us 2y squared minus 9y minus 5 equals 0. So next we're going to factor 2y squared minus 9y minus 5. So again, we look for the greatest common factor. In this case, again, it's 1. So next we're going to use our AC method. We're going to multiply 2 times negative 5, and that gives us negative 10. And we're going to write down our factors of negative 10. And we're looking for the pair that adds to a negative 9, and that's 1 plus negative 10. So we're going to rewrite using 1 and negative 10 to rewrite negative 9y. And then we're going to factor by grouping. So in the first group, the greatest common factor is y, and that would leave us a 2y plus 1. And remember, since this is negative, we're going to factor out a negative, and the greatest common factor of 10y and 5 is 5. And remember, that better give us the exact same thing. So negative 10y divided by negative 5 is positive 2y, and negative 5 divided by negative 5, anything divided by itself, is positive 1. So our greatest common factor is 2y plus 1. And when we divide it out of each term, that would leave us with y minus 5. Now remember, this is set equal to 0. And then we're going to set each factor to 0 and solve for y. So the first one, we're going to subtract 1 from both sides, and then divide by 2. So one of our answers is y equals negative 1/2. And for the second one, we're going to add 5 in order to isolate our y. And our second answer would be y equals 5.